Hi, welcome back to my channel. This is Pushpita here. In this section, I wish to continue class 12 topic relations and function. Let's discuss the topic composition of functions and invertible functions. In previous section, you have learned about the types of functions. Now let's see what does composition of functions. Let A, B and C be three non-empty sets and f from A to B and g from B to C be two functions. See the diagram? Since f is from A to B, then for every x belongs to A, there exists a unique element fx belongs to B. Since g is from B to C, then for every fx belongs to B, there exists a unique element g of fx belongs to C. Then the new function obtained from A to C is called the composition of f and g, and it is denoted by g circle f or g of fx. From the diagram, you can see that range of f is equal to domain of g. Let us formally define. Let f from A to B and g from B to C be two functions. Then the composition of f and g denoted by g circle f is defined by g circle of x equals g of fx for every x element A. Let's do some questions. If f is from set 1, 3, 4 to set 1 to 5 and g is from set 1 to 5 to 1, 3 given by f is equal to 1, 2, 3, 5, 4, 1 and g is equal to 1, 3, 2, 3, 5, 1, find g circle f. From f and g, you can see that range of f is equal to domain of g. Since f1 is equal to 2 and g2 is equal to 3, we get g circle of f1 equals g of f1 is equal to g2, that is equal to 3. Similarly, g circle of 3 is equal to g5 is equal to 1. G circle of 4 is equal to g1 is equal to 3. Hence, g circle of is equal to 1, 3, 3, 1, 4, 3. If f and g are from R to R, be two functions defined as fx is equal to modulus x plus x and gx is equal to modulus x minus x for every x belongs to R. Find f circle g and g circle f and hence find f circle g minus 3, f circle g of 5 and g circle f of minus 2. Given fx is equal to modulus x plus x and gx is equal to modulus x minus x for every x element R. We know that for modulus function, modulus x is equal to x if x greater than 0, 0 if x is equal to 0, minus x if x less than 0. When x greater than 0, we get fx is equal to x plus x is equal to x, gx is equal to x minus x equal 0. When x less than 0, we get fx is equal to minus x plus x equal 0, gx is equal to minus x is equal to minus 2x. That is fx is equal to 2x if x greater than 0, 0 if x less than 0 and gx is equal to 0 if x greater than 0, minus 2x if x less than 0. Now for x greater than 0, g circle of x is equal to g of 2x equals 0. Replacing x in gx by 2x, that is 2x minus 2x equals 0. For x less than 0, g circle of x is equal to g0, that is equal 0. For x greater than 0, f circle gx is equal to f0, that is equal 0. For x less than 0, f circle gx is equal to f of minus 2x, that is minus 2x plus minus 2x, that is equal to minus 4x, replacing x by minus 2x in fx. Now, g of fx equals 0 for every x element R. f of g of x equals 0 for x greater than or equals 0 minus 4x for x less than 0. Since 5 is greater than 0, f of g of 5 equals 0. Minus 3 less than 0. So we get f circle g of minus 3 equals minus 4 into minus 3 equals 12. Also, g circle of minus 2 is equal to 0. Moving to the next question. If the function f is from R to R defined by fx is equal to x square plus 2 and g is from R to R is given by gx is equal to x upon x minus 1, x not equals 1, then find f circle g and g circle f and hence find f circle g2 and g circle f minus 3. See the question. Given that f and g are from R to R, fx is equal to x square plus 2 and gx is equal to x upon x minus 1. Now, f circle gx is equal to f of x by x minus 1. That is equal to x by x minus 1 the whole square plus 2. Replace x in fx with x by x minus 1. That means x square upon x square minus 2x plus 1 plus 2. That is equal to x square plus 2x square minus 4x plus 2 divided by x square minus 2x plus 1. That is equal to 3x square minus 4x plus 2 divided by x square minus 2x plus 1 for every x element R. And g circle of x equals g of x square plus 2. That is equal to x square plus 2 upon x square plus 2 minus 1. Replace x in gx with x square plus 2. That is equal to x square plus 2 divided by x square plus 1. Therefore, f circle g of 2 equals 3 into 2 square minus 4 into 2 plus 2 divided by 2 square minus 2 into 2 plus 1. That is equal to 12 minus 8 plus 2 divided by 4 minus 4 plus 1, that is equal to 6. Now, g circle of minus 3 equals minus 3 square plus 2 divided by minus 3 square plus 1. That is equal to 11 upon 10. The composition of function is not commutative. That is, f circle g is not equal to g circle f. Let us discuss what is an inverse function. Inverse function. An inverse function is a function that reverses another function. See the mappings. Here, f maps 1 to b and g maps b to 1. F maps 2 to c and g maps c to 2. F maps 3 to a and g maps a to 3. Also, f is a bijection, that is 1 1 and on 2. And f circle g and g circle f are identity functions. So, g is called an inverse of f and it is denoted by f inverse. Now let us define. Definition. A function f from x to y is defined to be invertible if there exists a function g from y to x such that g circle f equals ix and f circle g equals iy. The function g is called the inverse of f, where ix is called the identity function on x and iy is called the identity function on y. See the diagram. X equals f inverse y is the range of g, that is f inverse. If f is invertible, then f must be 1 1 and on 2. For example, let f is equal to 1 12, 2 13, 3 11 and if f is bijective, then f inverse equals 12 1, 13 2 and 11 3. Question 1. If f is an invertible function defined as fx is equal to 3x minus 4 upon 5, then write f inverse x. Given fx is equal to 3x minus 4 upon 5 is invertible, that is f is 1, 1 and on 2. Let y is equal to 3x minus 4 upon 5. We get 5y is equal to 3x minus 4. That is 3x is equal to 5y plus 4. Now x is equal to 5y plus 4 divided by 3. We know that x is equal to f inverse y. So that f inverse y is equal to 5y plus 4 upon 3. Replace y with x, we get f inverse x is equal to 5x plus 4 upon 3. See the next question. Consider f is from r plus to negative 5 infinity given by fx is equal to 9x square plus 6x minus 5. Show that f is invertible with f inverse y is equal to square root of y plus 6 minus 1 upon 3 and hence find f inverse 163. See the question. The function is defined from r plus, but the interval is from negative 5 to infinity. Since the function is from r positive, consider the positive reals. Now we have to show that f is invertible. That is, f is 1, 1 and on 2. Let's check 1, 1. Let us assume that fx1 is equal to fx2 for every x1, x2 element r plus. 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. Now we get 9x1 square minus 9x2 square plus 6x1 minus 6x2 equals 0. Now 9 into x1 square minus x2 square plus 6 into x1 minus x2 equals 0. Applying the identity a square minus b square is equal to a minus b into a plus b, we get 9 into x1 minus x2 into x1 plus x2 plus 6 into x1 minus x2 equals 0. Taking common factor x1 minus x2, we get x1 minus x2 into 9x1 plus 9x2 plus 6 equals 0. Since x1 and x2 belongs to r positive, 9x1 plus 9x2 plus 6 not equals 0. Therefore, x1 minus x2 equals 0. That is x1 equals x2. Hence, f is 1, 1. For on 2, let y is equal to 9x square plus 6x minus 5. That is 9x square plus 6x equals y plus 5. Taking 9 from RHS, we get 9 into x square plus 6 by 9x is equal to y plus 5. That is 9 into x square plus 2 by 3x equals y plus 5. Inside the bracket, add and subtract half coefficient of x the whole square. That is 1 by 9. We get 9 into x square plus 2 by 3x plus 1 by 9 minus 1 by 9 is equal to y plus 5. Now, first three terms in the bracket together form a perfect square. That is 9 into x plus 1 by 3 the whole square minus 1 by 9 is equal to y plus 5. Open the outer bracket with 9, we get 9 into x plus 1 by 3 the whole square minus 1 is equal to y plus 5. That is 9 into x plus 1 by 3 the whole square is equal to y plus 6, which implies to x plus 1 by 3 the whole square is equal to y plus 6 divided by 9. Taking square root, we get x plus 1 by 3 is equal to square root of y plus 6 upon 3. That is, x is equal to square root of y plus 6 minus 1 upon 3 for every y element negative 5 infinity. That is, range is equal to codomain. Therefore, f is on 2. Since f is 1, 1 and onto, f is an invertible function. F inverse y is equal to square root of y plus 6 minus 1 upon 3. Now, let us find f inverse 163. That is equal to square root of 163 plus 6 minus 1 upon 3. That is equal to root of 169 minus 1 upon 3. That is 12 by 3 is equal to 4. Coming to the next question. Let f from n to n be a function defined as fx equals 4x square plus 12x plus 15. Show that f is from n to s is invertible where s is the range of f. Find the inverse of f and hence find f inverse 87. See the question. Let us try another method to prove f is invertible. According to the definition, you have learned that if f is invertible, then g circle f is equal to ix and f circle g equals iy. Given that fx equals 4x square plus 12x plus 15, let us take y is equal to 4x square plus 12x plus 15. Now we get 4x square plus 12x plus 15 minus y is equal to 0. It is a quadratic equation. Use the quadratic formula. We get x equals negative 12 plus or minus root of 12 square minus 16 into 50 minus y upon 2 into 4. That is equal to negative 12 plus or minus root of 144 minus 240 plus 16y upon 8. That is equal to negative 12 plus or minus root of 16y minus 96 upon 8. That is equals negative 12 plus or minus root of 16 into y minus 6 upon 8. That is negative 12 plus 4 into root of y minus 6 upon 8. That is equal to negative 3 plus or minus root of y minus 6 upon 2. Since x belongs to n, let us take gy is equal to negative 3 plus square root of y minus 6 by 2. Now g circle f equals g of 4x square plus 12x plus 15. That is equal to negative 3 plus square root of 4x square plus 12x plus 15 minus 6 upon 2. That is equal to negative 3 plus root of 4x square plus 12x plus 9 by 2. Now we get negative 3 plus root of 2x plus 3 the whole square by 2. That is equal to negative 3 plus 2x plus 3 by 2. That is equal to x, that is ix. Now f circle g is equal to f of gx. That is equal to 4 into negative 3 plus root of y minus 6 upon 2 the whole square plus 12 into negative 3 plus root of y minus 6 upon 2 plus 15. That is equal to negative 3 plus root of y minus 6 the whole square plus 6 into negative 3 plus root of y minus 6 plus 15. Using the identity a minus b the whole square, we get 9 minus 6 into root of y minus 6 plus y minus 6 minus 18 plus 6 into root of y minus 6 plus 15. That is equal to y. That is, therefore, f is an invertible function. Now, f inverse y is equal to negative 3 plus root of y minus 6 upon 2. F inverse 87 is equal to negative 3 plus root of 87 minus 6 by 2. Negative 3 plus root of 81 by 2, that is equal to negative 3 plus 9 by 2, which is equal to 3. Now let us learn two theorems. Theorem 1. If f from x to y and G from Y to Z and H from Z to S are functions, then H circle G circle F is equal to H circle G circle F. That is, composition of function is associative. Theorem 2. If F is from X to Y and G is from Y to Z be two invertible function, then G circle F is also invertible with G circle F inverse is equal to F inverse circle G inverse. Let's do a question. Let A is equal to set 1, 2, 3, 4, B is equal to set 3, 5, 7, 9, and C is equal to set 7, 23, 47, 79. And F from A to B, G from B to C be defined as Fx is equal to x plus 1 and Gx is equal to x square minus 2. Express G circle of inverse and F inverse circle G inverse as the set of ordered pairs and verify that G circle of inverse is equal to F inverse circle G inverse. Given Fx is equal to 2x plus 1 and Gx is equal to x square minus 2. To find the range of f, use Fx is equal to x plus 1. Now we get f is equal to 1, 2 into 1 plus 1, 2, 2 into 2 plus 1, 3, 2 into 3 plus 1, 4, 2 into 4 plus 1. That is 1, 3, 2, 5, 3, 7, 4, 9. Similarly, to find the range of G, use Gx is equal to x square minus 2. Now G is equal to 3, 3 square minus 2, 5, 5 square minus 2, 7, 7 square minus 2, 9, 9 square minus 2. That is 3, 7, 5, 23, 7, 47, 9, 79. Clearly, F and G are bijective. Now F inverse is equal to 3, 1, 5, 2, 7, 3, 9, 4. G inverse is equal to 7, 3, 23, 5, 47, 7, 79, 9. Now F inverse circle G inverse is equal to 7, 1, 23, 2, 47, 3, 79, 4. Now see, G circle of X is equal to G of 2x plus 1. That is equal to 2x plus 1 the whole square minus 2. That is equal to 4x square plus 4x plus 1 minus 2, which gives 4x square plus 4x minus 1. Now G circle of 1 is equal to 4 into 1 square plus 4 into 1 minus 1 is equal to 7. G circle of 2 is equal to 4 into 2 square plus 4 into 2 minus 1, that is equal to 23. G circle of 3 is equal to 4 into 3 square plus 4 into 3 minus 1 is equal to 47. G circle of 4 is equal to 4 into 4 square plus 4 into 4 minus 1, that is equal to 79. Now G circle of is equal to 1, 7, 2, 23, 3, 47, 4, 79. Now G circle of inverse is equal to 7, 1, 23, 2, 47, 3, 79, 4. That is, G circle of inverse is equal to F inverse circle G inverse. That's all from the first chapter. Questions which I have discussed in all the videos are taken from the board question papers. So study well. Don't forget to subscribe and share my channel. Thank you.